Good evening. My name is Naveed Rehman, and I today I'm going to be talking about network graphs as an assignment for UMGC data visualization class 625. Professor is Joel Wemak. So today we are going to take a look at two different networks and do a comparison or analysis between the security for these two networks. One is network 2 and the other one is network 3. Both of them have equal number of employees. And so when we look at network 2, we can see that there are multiple different nodes. The most prominent are the 7 nodes, which are right here. A node with many edges going into it with higher brightness, and that's what it shows. That node which has many different um, edges going into has much higher brightness. So brightness lets us know a certain node acts as a bridge. So it's like a bridge, and so there are 7 of these right here. And then there are these edges, the linkage between the two nodes. As you can see, if I hover over it, it says edge ID 16. So it is the edge or the linkage between Stealth and Spectre. So this is network 2 with many multiple bridges. Um, um, no one hub is or one bridge is critical. Load is spread throughout this network. Um, Messages still, if a hub device goes down, messages still mostly get through alternate alternate bridge which exist in here. Whereas when we look at network 3, it is like a tree. If you can if you look at this, it is similar to a tree. um, it is a fragile. If either hub device does not goes down, it goes down. Every leaf with attached only to their hub is cut off completely. No alternate path. For example, if this edge is affected by a malware, the lands on. So the if this edge or this hub is affected by a malware, it so it would be difficult to pass on any of the information. At a minimum, a backup link from the key branch to a second hub and is needed in this case. So looking at these two different networks, um, not looking at the head counts, how many independent paths connect any two nodes is what determines resilience and not size. Network 2 interconnected hub means there is no network node whose failure um, so this one right here, network 2, whose failure no one node or bridge is responsible for network failure. Network 3, which is nearly like a tree, as explained earlier, means a handful of nodes are structural bottlenecks. Losing one does not just slow things down; it practically partitions this network, just like I explained earlier. So Strawhawk and the edge between Nibla. If a malware is attacked on this network, it would be difficult to keep this network up and running. Um, that's the core messages I want to give to the client, that these two networks are two different networks. One is a tree-like, whereas the other has multiple different hubs and bridges. If one network, if one hub is compromised, there are other ways to send the message.